GCSE question of the week, week 2, part 2. Okay, so let's go back to David with his lovely cooker. Imagine we're on the calculator paper and we get a similar question. Still costs £320. He's still got to pay a deposit, but this time the deposit's 18.5%. So that makes our method from last time look less attractive. There's a much better way of doing this question. Okay, so what we're going to do is we're going to realise that we've still got £320. That's still worth 100%. What we're going to do with our 18.5% is we're going to turn that into a decimal. And remember, to turn a percentage into a decimal, we just need to divide by 100. Okay, so that 18.5% divided by 100 is going to give me 0.185. Okay, so those digits have moved 2 places to the right, or if you prefer, that decimal points jumped 2 places to the left. So 0.185. Right, what we can then do is we'll take our £320 and we'll simply times it, multiply it by that multiplier, 0.185. Okay, so it's a calculator paper this time. We can do 320 multiplied by 0.185. Okay, that gives us £59.20. So we get £59.20. Right, now we've changed the question slightly again. David's still going to buy the cooker, still got a price of £320. He still pays a deposit of 18.5% of the price of the cooker. This time though, the question says how much money does David still have left to pay? So he's already paid the deposit. We've got to work out how much he's got to pay left after he's paid the deposit. So again, I'd like to try and use the multiplier method. This time, the multiplier is not going to be based on 18.5%. That's what he's already paid. Okay, so you need to work out what percentage he's still got left to pay, then convert that into a decimal to use as our multiplier, and then use the multiplier multiplied by the £320. Okay, pause the video, have a go, and then check up. Okay, if you got the multiplier as 0.815, excellent. And then if you then use that to multiply by 320 and got £260.80, fantastic. Now obviously, if we add that up together with our £59.20 from the last question, that should give us our 320, and it does. So we're good to go. Now onto the higher tier question. We've got a carton of orange juice. The carton's in the shape of a cuboid. The depth of the orange juice in the carton is 8 centimetres. Okay, so 8 centimetres means that this orange juice doesn't fill up the whole container, and this dimension here is 8 centimetres. So the orange juice is filling up the bottom of this container. Something like that. Okay, so there's our orange juice. Now the first thing we can do is work out our volume of orange juice. And in order to do that, we need to know the volume of a cuboid. So the volume of a cuboid is the length times the width times the height. So what have we got for our volume? Well, we've got volume equals, let's say, the 10 times the 6 times the 8. It really doesn't matter which order those are in, as long as they're the right 3 dimensions. So the 10 times 6 times 8, well, 6 times 8, I think that's 48. Okay, multiply that by 10, this must be 480. And 480 cubic centimetres, because we've got a volume. We've multiplied centimetres by centimetres by centimetre. So 480 cubic centimetres. And we know that volume's constant. The volume of the orange juice is not going to change. But what Jane does now is she turns the carton over so that it stands on the shaded face. And the shaded face is this front face here. So she now turns it over so that face is facing downwards. So on the base, that face is now on the floor. So that base is the 6 times the 20. This is 20. So it's the 6 times the 20 that are now on the floor. Okay, and the rest of the container will be up here. Something like that. Okay, so our orange juice has now sloshed around in the bottom, and it's somewhere down the bottom of the container, and we want to know how high it now is. So it's filled up the shape of this container. Something like this. How high is it now? Let's call that H. Okay. Well, we know that the volume's still the same. The volume's 480 cubic centimetres. And how would the dimensions that we've got here make up that 480 cubic centimetres? Well, we know that the 6 and the 20 are the dimensions along the base. So the 6 times the 20 times the height must be equal to 480 cubic centimetres, because our 6 times our 20 times our height, I've got to give it the volume of this cuboid here, the volume of the orange juice cuboid. Okay, so I've got an equation that says 6 times 20 times H equals 480. Well, we can simplify that. 6 times 20, that's going to be 120. So we've got 120H equals 480. So what do we need to do now? Well, 120 times H times 120, we'll divide by 120. So that'll give me H is equal to 480 divided by 120, which I make 4. So our height's 4 centimetres. Now, certainly some people in my group had a much more elegant solution than that, and they simply visualised what was going on. They thought, well, at the moment, the base area here is the 6 times 10. It will be 60 square centimetres. And when we flip our carton over, the base then becomes 6 times 20. 120 square centimetres. But they just said, well, the 6 is the same in each one. So really, this dimension, this 10, has doubled. This 10's turned to a 20. So if the base is twice as wide, the area is twice as wide, they reasoned that the depth here, the height, must be half what it was before. Okay, it was 8 before, and they reasoned that it now must be 4 centimetres, which was a very clever way of thinking it through. If that was you, yay, well done. Brilliant. Either way, 4 centimetres, I've called it the height here, but 4 centimetres is the depth of the orange juice.